This presentation is on automated acceptance testing with behavior-driven development and PHP. So what do we have here? This is a picture of the Challenger exploding. Does anybody know what the story is? Well, obviously not, because I'm talking to my computer. But the failure was caused by an O-ring that corroded or deteriorated because of the cold, which caused the hot gases from the booster to explode into the side of the fuel tank, which caused this to go boom. And when they were trying to justify the data for this, for trying to abort the launch, they presented something that looked like this. So here is how this data was presented. It's in chronological by launch with the temperatures and the location of the damage, but it's kind of confusing. And you look at this and you can see, okay, that's a lot of rocket boosters, but what are you trying to tell me? But if you reformat that same data, you get an image that looks like this, which tells a much more compelling story. And you see the one axis is the temperature and the other is the amount of damage. It's a lot more simplified, and you can see extrapolated where that damage points to and the temperature that they launched at. And typically these two images are used to promote good data visualization. One is much more clear, one conveys a lot more information than the other, even the same data is there. I would say this, in this context, screams for the need of a common language when you're into design situations. So for the booster engineers, perhaps this data made complete sense with all the rocket boosters. You know, it communicated in sort of their technical minds significant amount of information. But for the lay person, this chart here screams, oh man, there's going to be a problem. And what it gets to the heart of is that we don't all think alike. If most of the people watching this are probably some sort of software engineer, not everybody thinks like us. So product managers don't think like you. QA engineers also don't think like you. And business people just don't think like you. But I guess they think sometimes. So because of this, we need a consistent way to talk about the thing we're building. So we can say that a nail is in fact a nail, an O-ring is an O-ring, and something like a Mongo user repository is a Mongo user repository. And in this presentation, I want to offer that behavior-driven development, or BDD, is a strategy to gain this common language amongst your stakeholders. And then through that common language, automate the key acceptance tests of your applications. So my name is Jason Fox. I'm an independent consultant that specializes in test automation and code craftsmanship. I also help run the Elemental Selenium newsletter, which is an email newsletter that provides tips on how to use Selenium. And I wrote a little book called the Chef Survival Guide, which is about setting up the Chef infrastructure automation tool. I also like to ride and customize motorcycles in my spare time. All right, so what is BDD anyway? What is this? Let's get down into it. So Dan North, who pretty much invented BDD, had this to say. It describes the cycle of interactions with well-defined outputs resulting in delivery of working, tested software that matters. And I would take that quote and summarize it into 3 points a little bit further. So first and foremost, behavior-driven development is a way of interacting with your coworkers, your stakeholders. Ultimately, this strategy should start a conversation. Secondly, it's a way of describing your behavior through the use of a strict human-readable language called Gherkin. Thirdly, you complement this process with a set of tools. It's a way of testing, namely Cucumber, which has been developed mostly for Ruby applications, or Behat for PHP. And today we're going to focus on the Behat library, but it's a method of testing your acceptance criteria. So to touch on the interaction portion, it's fundamentally it's a way of interacting. Your stakeholders have to have these hard conversations with each other, and you have to accomplish real work in those planning meetings. You can't just gloss over things, and in an effort to get back to your desks. It's important that each of the sort of three amigos, which on this slide here, the QA people, the engineering, the product, they work together. And what we'll need to do is we'll need to break down these walls. And here I have walls with really sharp spikes on them because often that's what it feels like. It's kind of crazy. People go into the office and they think, well, I'm just going to code or I'm just going to test. The only time you interact with people is when you're sort of in this formalized meeting setting. It's kind of like, oh, it's okay to talk about this stuff. Whereas this really should be every day. We should break these walls down, have everybody working on the same page, speaking the same language. And because we're all thinking differently, each of those actors can challenge each other's assumptions, and we come to sort of a better and more common understanding of what we're trying to build. So the product manager might ask, who is the user here? How can I describe this functionality in terms of what the user wants? Either as me describing what I want in terms of what the user wants, or better yet, sort of directly describe the functionality that the user wants. We should ask questions that kind of get specific. What should the user see here, directly here? The more explicit you are, the less for chance of confusion and rework. You might have a situation where they say, well, there needs to be a button on that page, but unless you explicitly specify sort of its size, what's on it, the location, you might get another request days down the line to change a bunch of stuff that could have been settled with a simple conversation. Another situation, when the user is on password reset, what should they actually see? Not just a form. What fields, what are the names of the fields, what's the workflow? Get as explicit as possible. Also asking about edge cases. What should happen if blank occurs? And QA engineers are great about this. Software engineers, we ship gold. Everything we do is perfect. It's going to work fine. No, there's no errors at all. In QA, they sort of have the devil's advocate mentality. Well, what if the request does fail? What should the user see then? Fleshing out more of the requirements of the application. And most importantly, how do you know when you're done? What does done look like? I personally could keep tweaking on the performance or cleaning up the code or fiddling with this or that or improving the API. Designers could continue to freshen up the page and make it look cleaner. What we want to get to the heart of is sort of what are the questions that, when answered, will tell us that we're done with this story, or this sprint, or this product. So this just comes back to having a conversation, having everybody in the same room or in the same work area or on the same schedule so that they can get that continuous honing of what the product is going to be. So, having these deep, passionate discussions about the product you're building and what's at stake. And I think this is probably the most important part of BDD that doesn't get really talked about because it's a lot easier to, buy a bowling ball than it is to learn bowling. But the conversation is key, and if you get that right, the next two parts of BDD will occur naturally. Once you're having these productive conversations in a common language, you'll start to want to codify this behavior, which brings us to the next slide. Suspenseful pause. What are these things? So these are gherkins, which I enjoyed in their pickled form before I was a software engineer and before I was into behavior-driven development. And I believe that they're called that because Cucumber is one of the testing libraries. These are also the name of this standardized language that you can codify your behavior in. And the best part is that it can be, it's standardized, it's consistent, and it's automatable. And the basics of this language take the form of the words given, when, and then. So given some preconditions, sort of given the state of the world is like this, what has to be in place for this behavior to occur, or sort of what is the context of your behavior. Then when a user does something, sort of what is the action in the behavior? What is the trigger that causes something to happen or a state to change? Sort of what is this turning point or the event that you're interested in? And then finally, what is the outcome? Then this should happen. How do I know that the behavior is correctly exhibited? And this is where sort of the unit test style assertions come in. You want to assert that certain things have happened correctly. So when trying to turn your behavior into sort of givens, whens, and thens can be a little daunting at first. And if I'm teaching somebody to do this, I sort of say, close your laptop, put away your software mentality, and just talk directly to me. In human terms, we're just having a conversation here. What should happen? And then once we have that down, we can kind of translate it back into this more formalized language, honing it to get ultimately to it's written in Gherkin. So maybe they want to build a login screen. Well, why? What's the purpose? Oh, so the user can log in. Well, what has to happen for them to log in? What has to happen first? Well, they have to, be on the login page. Well, see, that's starting to sound like a precondition. They have to be on product.com/login. Okay, we're getting there. So given I am on product.com/login, then what do they do when they're on this page? Well, they fill in the form and press submit. Okay, well let's clean that up a little bit. Let's get a little more explicit. Oh, well, then they fill in their username and their password and they press the submit button. All right, then what? Okay, well then we should be on the home page. And how do you know is the question I would ask. Okay, well they should see welcome Jason. And so you take something that's very human readable or very conversational and you translate it into just a slightly more strict version of the language, which can then be translated into automated tests. So here's a real example of this in the Gherkin language and using sort of extensions to that language that pertain to testing of a web application. Notice that this is quite human readable. Sort of anybody involved with this product should be able to know exactly what we're trying to build here. So I'm going to go through each line of this feature and describe kind of what's going on. So before we even describe what's happening, we sort of write out a description of the scenario, which is what we're trying to describe for the whole test. So all scenarios they're groups of givens, whens, and thens. So in this case, the scenario, the user can log in. So here's the first precondition. So what this is assuming is that we already know, or we already are going to know, that we're going to sort of product.com or whatever your domain happens to be. And so there are some assumptions baked into the descriptions, and part of these are captured in the tool that we would use to automate the testing of these behaviors. The second precondition, and I fill in username with jfox. Here, and is just a cleaner way of repeating the word given. You could say given this, given that, but better to say given and. And notice that I'm also using sort of real words and real data here. jfox, not just a random username. And by being this explicit, we're sort of starting to give our test users these identities. And so we think about them as real situations, real behavior. Here's the third precondition, and I fill in the password with secret. And in here, there's another assumption about allowable passwords. We sort of assume that the $sign and the 3 and the length are adequate for our password. But we're not really testing that there. It's just something to consider. Then the action, the when statement, when I press login, this is the point where something will change in the application and that we want to measure that some behavior has been exhibited. And then after that happens, we want to verify sort of that I should be on this new URL path, and also that I should see welcome JSON. And also suddenly we see that our test user has a name, because that must have had to been stored somehow in the application. So this very simple high-level description of the login page will spark lots of other questions, which will trickle down into lower level tests. Sort of what attributes should the user have, what types of passwords are allowed, how will errors work, and this is all good, and this is exactly what this collective conversation should promote from these sort of more simple high-level test cases. So this would not obviously be a presentation about testing if I didn't include a picture of this test pyramid. And we can see that BDD is ultimately just one key part of a test-driven approach. It's up here at the top of the pyramid, just behind manual testing, because there sort of should be a lot less of these behavior tests than there should be of integration or unit tests, because you're describing those high-level behavior and the happy paths, which will prompt the questions that I mentioned earlier. And then the specifics of those questions are defined lower and lower. Your integration tests might validate the errors of logging in. Your unit tests might determine which passwords are allowed. And so that will bring us to the final piece of the puzzle. Once we've interacted with stakeholders and described our behavior in a consistent, codified way, we have to, of course, automate the applications of these tests. And automation is important because we gain repeatability and efficiency, and we have that constant gut check when developing any new functionality. You want to ensure that sort of your users will always perhaps log into your application or, make a purchase, and having an automated acceptance test, they'll ensure that you'll always have your money maker will always be able to work. And this is where BHAT comes in. So BHAT is a testing library written and implemented in PHP that does the processing and automation of your scenarios, or the collection of those scenarios, which are grouped into files called features. And it's important to understand that BHAT alone is not doing BDD in the same way that a robotic welder is not an assembly line, or attending Scrum meetings makes your team agile. It's a cohesive part of a process, and the tool has to be implemented and used in conjunction with well-written Gherkin and having these good conversations in order to provide value. But on the same token, you can also write your Gherkin test cases without using the BHAT software. It can be a good sort of low-cost way to get into behavior-driven development or acceptance test automation is if you get your team to agree, okay, well, we're going to write our features in this language. That's all we're going to do. We won't spend expensive development time implementing this. And then that's just one step closer to getting to a fully automated solution. There's often a bit more to it than just the BHAT library. There's some other tools that interact, and so for web application testing, the tool chain might look a bit like this. So you have a collection of features written in Gherkin, which are then translated by BHAT which is extended with this Mink plugin, which gives you the specific tests and language to describe web applications. And then all that is used to drive some testing facility such as Selenium or another headless browser like Phantom or Goot. And that's why I think some of this stuff that we've looked through previously, seems pretty simple, because the Mink extension is adding all this helpful language that lets your Gherkin describe web application behavior. But this slide here shows sort of an arbitrary description of functionality, and if you were to run this alone, you would get an error. You'd get a method pending or a undefined step error, which gives a comment of the code that you need to implement this feature. And there's a file in your BHAT setup called the feature context, and inside that's where you're going to put all these context functions, which will let you translate your human-readable Gherkin features into the executable tests. And you'll notice that the 2 that I put in quotes in the previous slide has been translated into an argument in this function. Given I do blank things, and then that number is passed in as an argument. And so that allows me to make this function a little more flexible, and building out a library of domain-specific flexible test functions. So I can choose sort of from a library, or I can modify these in different situations. And going with this example from before, the reason this is not going to fail is because that Mink extension has already implemented a function for this test case, which looks something like this. It's a little bit more complicated, but all they're really doing is cleaning up the 2 arguments and then using a helper function to get the browser session, get the page, and then fill in the field. And I would say that you can get pretty far. You can go a long way with just using the stock Mink context functions, and either using them directly or wrapping them in your own helper functions that improve readability of your Gherkin files. So perhaps that whole login scenario could be wrapped in given I log in as user with password, and it does the filling fields and submit button pressing for you. So finally, the last part I want to mention about the Behat is just brief on setup. So part of this presentation, I have included at the end a link to a fully working example with all the setup and features. So I don't really want to get too deep into the technical details, but basically you can install this, you can install Behat with Composer, put it right into your project, and then I like to set up my folders as shown here. So I have a test/system tests directory, under which I have configuration, features. In the config directory, I have the behat.yaml file, which is where I would specify things like how I want the results of my test runs to be reported, which browser driver I want to use, either Selenium or Phantom or something like that. And also, like what I mentioned earlier about that base URL, that sort of product.com that all the paths are relative to. Under the features folder is where we put all the features. Each feature has the extension .feature, and it contains a bunch of scenarios with their givens, whens, and thens. And under that folder is also this bootstrap folder, which contains the feature context .php file that has all those implemented context functions and other files that help you change your Gherkin stuff into implementable tests or runnable tests. And so that's the setup of Behat. Now I want to end with 3 sort of bad habits, anti-patterns that can give you trouble when using BDD. Sort of not so much the conversational stuff, because you can get into a lot of trouble, before you can even have a conversation with your coworkers. This is specific to Gherkin writing or feature implementation. The first one is something like this: app.-123.feature. Using stories or Jira ticket numbers, they're not the same as features. No, this is a big no-no. Creating a feature with the name of a ticket is just wrong, and the reason is because a feature should describe sort of timeless application behavior. If the behavior changes, you can update the feature or delete the feature, but a ticket is an artifact of development. It's sort of pertinent to a sprint or pertinent to a workflow tool. They get deleted and rewritten and moved around. You might have a story that's ticket 123 that describes login that ends up being broken out into 2 different ticket numbers because there's one type of login, there's an admin login, and then suddenly you have to change your feature name. You should not do this. Every time I see this, I cringe. They're completely separate concepts. And I would say a better use would be something like login.feature, because that name says this describes the login behavior. Whatever that may be, this feature will capture it. The second anti-pattern is something, like given this and that and this and that. You want to avoid too much context, too much setup to the situation. No, because this obscures what you're actually testing. It hides the thing you're testing in like 1 or 2 lines, and it makes your tests really boring because they read kind of like a spec and not like a story. Here's an example. The user can pick an avatar. So given I'm on login and I fill in username and I fill in password and I press login and I go to profile and I click on avatars and I click on cool dude. When I click save, I should see avatar updated or whatever. That's a lot of stuff. There's a lot going on here, and we forget that it's actually only really clicking on a thing and saving and verifying that that worked. And so this is boring. I don't want to read all through these things. I want to know directly what's happening. So a better strategy would be to wrap all that preconditioned stuff into a more explicit context function. So rewriting that might look like this. Given I access the profile avatars page and I click on that and I click save, then I should see the confirmation. It's much cleaner. And so this is the reason that you need to, as a team, collectively groom your context functions over time. Because by changing it, kind of putting a stake in the ground and saying, so there are lots of sort of generic actions that our users will take, and that in order to do those actions, they require to go to a specific page after authenticating. And we don't really care what user is doing that, just that the behavior is correct given this context. And so behind the scenes, at the given I access blah, 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 it will log the user in and go to that page. And so this back and forth of custom functions and building your Gherkin dictionary, that needs to be very open and collaborative, because when you're writing future behaviors, you'll sort of want to know what statements are available so you don't have repeat, and you kind of have a common set of tools you can put together to describe new features in your domain. And then the final anti-pattern is mumbo jumbo. So this is also a no. You want to get the mumbo jumbo out. Remember at the beginning of the presentation I showed that picture of all those rocket boosters. That's a lot of technical mumbo jumbo that doesn't tell the story. You should avoid that in your Gherkin features just the same, because they're going to serve more than just the engineers. In some situations, if your project and your stakeholders and everybody is sort of speaking a much more technical common language, that's appropriate to make your features more technical. But really, you want to sort of err on the side of simple lay speak, making sure that your audience is as wide as possible so you can include all the stakeholders in the conversation. So here's sort of a bad example. Successful API user request. Given I have a valid OAuth token and I make a request, so this isn't a super complicated scenario, but there are some extra details that aren't really 100% required to all the parties involved. And making those details explicit in this test, like get and the error and the response code, that's kind of pulling your unit tests up into your behavioral tests, because that stuff can be verified at a much lower level. Of course, a successful response will have this 200 code, but that fact is much more general to HTTP requests and not really relevant to testing your API design. So we should clean this up to make it a bit more readable and a little bit less technical. Given I've authenticated and I request that path, then my response should contain JFox. So not only did we remove a few steps, but we abstracted some of the technical details into these context functions. So for example, the when statement knows how to issue a request. And a then statement will assure that the request is successful. It may assert behind the scenes that you get 200 back before checking the response. So those are three main anti-patterns. And so to review BDD, ultimately it is just a very important strategy for interacting so that your whole team can have productive conversations. Secondly, it's a way of describing your behaviors with the Gherkin language. And finally, it is a way of automating those acceptance tests with some great library software like BHAT. So that is BDD with PHP, BHAT. Thanks for watching. And if you go to this link, the github/jasonrobertfox/demo-sauce-labs, you can see a PHP implementation of a small application and BHAT with headless, Selenium, and Sauce Labs testing, and learn about all the setup stuff there. So thank you, and be sure to check me out on Twitter or GitHub. See you later.